Now we are going to learn how to simplify using two-variable K-map. So these are the steps in simplifying a Boolean expression using a K-map. So first, you have to write down a sum of product expression from the truth table. Second, plot a 1 on the K-map for each product term, or plot a 1 on the K-map for each output y equal to 1. Third, draw loops around adjacent cells containing two ones on the K-map. The loops may overlap. Fourth, repeat step 2 and 3. Fifth, each loop produce a simplified product term. Sixth, logically OR the simplified product term. To make you clear, I will explain based on questions. Let's try to look at example 1. The question is, simplify the OR gate truth table using K-map. So this is two inputs OR gate truth table. We have A and B only. Recall back, for OR gate, it will produce output 1 when one of the inputs is 1. Okay, so you can see that when only 0, A0, B0, output Y is 0. The rest will be 1. Okay, now let's try to get the simplified equation for these two inputs OR gate truth table using K-map. Okay, let's try to draw the K-map. Okay. So we have two inputs, A and B only. So we are going to have 4 cells, 2 to the power of 2. So we start with A bar, A, adjacent cell A, then B bar, then B. Okay. So the small number inside each cell is optional. Okay. For OR gate, A bar, B bar. For the first cell, A bar, B bar. A0, B0. A0, B0, the output is 0. Okay. Next, second cell, A, B bar. A1, B0. So, the characteristic of OR gate, when one of the inputs is 1, the output will be 1. So, we know that for OR gate, the output is 0 only when both A and B is 0. So, the rest of the input will be 1. So, we can directly plot 1, 1, 1. Okay. So we plot 1 on the K-map. Next, we draw the loop. Okay, we draw the loop. Okay, we draw the loop. Okay, we draw the loop for the adjacent 1. Okay, we draw the loop for the adjacent one. Okay, we have one loop here and one loop here. Okay, so we have two pairs. Okay, next we read the equation. So the product term, the common term here is A. So we can write the expression as A. The vertical common variable is A plus this one, horizontal common term is B. So the answer is A plus B. Y equal to A plus B. So that's how you simplify equations using K-map. So the answer is same with the answer on your slide. Okay. Okay, this is my answer and this is the answer on your slide. Okay, next, let's try another example. Simplify the NAND gate truth table using K-map. Okay, so here we have A bar, A, B bar, B. So A bar, B bar, 0, 0, output 1. So you plot 1. A bar, B, 0, 1, 1. And also A1, B0, A, B bar also 1. So this one, A1, B1, output 0, no need to plot. Next, you create loop for the adjacent one. So you're going to have two loops here. Then you find the common term for the horizontal loop. Okay, this one, the common term is B bar. Next, for the vertical one, the common term is A bar. Then, so the answer will be, for example 2, the answer is, okay, let's erase this one first. Okay, so the answer for example 2 is Y equal to A bar plus B bar. Okay, let's try to see example 3. Example 3, simplify the XOR gate truth table using K-map. Okay, so we plot A bar dot B, A bar dot B 1, A dot B bar 1. Okay, you cannot create loop for this pair because they are not in adjacent. Okay, so meaning that the expression couldn't be simplified. We cannot simplify the expression for XOR gate truth table. So the expression is maintained as the original one. Y equal to A bar dot B. So the SOP, sum of product. You still remember? Please recall back what have we learned in chapter 3, the SOP. Okay, SOP, you check which row produce output 1. So Y equal to A bar dot B plus with A dot B bar. Okay, we cannot simplify. Okay, because cell 1 is not considered adjacent to cell 2, both variables are different. So there is no common term for this. Okay, this one is A bar dot B, this one is A dot B bar. So there is no common term for both of the product term. Okay, next, let's try to see the simplification using three-variable K-map. A three-variable K-map allows loop containing 2, 4, and 8 ones. First, you have to draw a loop around adjacent cells containing 4 ones. A loop containing many ones will produce a simpler product term. So find out if there are other possible loops containing 4 ones. The loops may overlap. After finishing loops containing 4 ones, draw loops containing 2 ones. Okay, I will explain this based on example. Okay, let's try to see this one. Okay, we have this. Okay, let's try to draw together. So we have 8 possible output, 8 outputs for this truth table, meaning that we are going to have 8 cells. Okay, 8 cells. 8 cells. Okay, A bar, B bar. Okay, next A bar. Okay, defer only one variable, A bar, B. Then maintain B, then A. Next is A, B bar. Then C bar, C. Okay, so it will produce output 1, A bar, B bar, okay, A bar, B bar, C bar. Okay, plot 1. Next, A bar, B bar, C. A bar, B bar, C, 1 also. Next, A bar, B, C bar. Okay. Next, we draw the loop for the adjacent cells containing 1. Okay. Next, we find the common term. Okay. Okay. So we're going to write y. This one, common term. Okay, the common term is, you cannot say C bar. If you say C bar, this one also included. So you have to say it A bar, C bar. And then for this one, it is, the common term is A bar, B bar. So the simplified equation is A bar, C bar plus A bar, B bar. Okay. Same with the answer on your slide. A bar, C bar, A bar, B bar.